Hi, welcome to this Programming for Cultural Heritage lecture. We're going to talk today about regular expressions. So regular expressions are a way to interact with strings, and basically it's a way to extract structured data from a string. If we think about what strings are, we've done a little bit of work with various types of texts and characters and strings before, but we haven't really done much about manipulating strings or kind of looking inside of them and searching for them, etc., right? And so, for example, if you wanted to do a very simple task of like locating one piece of a substring in a bigger string, this is basically how you would approach it with just the kind of built-in Python methods for strings. You'd have a piece of text like this, it says hello there, and then you would need to find whatever piece you were looking for. So in this case, we're looking for the word there, and then every string has this dot find method built into it. So it will find whatever you're looking for within itself and then return a value of where it starts. And then you could start splicing up the string to get at that piece of text if you wanted to. So this is fine for like very simple things, simple of operations, but we can kind of go over it as an example here. So I'm going to make a new Python file here. I'll call it string test in my downloads. And so basically we're going to just recreate that slide that we just saw. All right, so we have a string. And if we remember from what our previous lectures, what strings are, they're basically just a list of characters, right? So you could actually print out my string and it's a list. So each character is an item in that list or element in that list. So if you did my string 0 and ran that, you would run into, let me try to switch over to that directory. And if we ran that, we'd see it printing out H, right? Because H was the 0 position of that string. So you can do all sorts of things with these list selectors. You can do select one element like this, but that's the position you want to find. If you use a colon, you can set a range. So I want to start from 0 and go all the way to 5, for example. And so that'd be 0, 1, 2, 3, 4, 5. So it'd be hello plus the space. So if you ran that and tried it, we'd see, right, there's hello and then there's a space at the end. You can't see it. But you can also do some other things, like some fancy things like -1, which represents the last position in the list. And so if we ran that, we would expect to see n, right? Because that's the last character in the list. So there's n. And then of course you combine these things together and say, okay, well I want everything from the 5th position until the end. And that would give you something like this. Minus out the last character, because it's not inclusive, right? Let's try -2, see what happens. No, okay. All right, so -1. So what we can do is, as we saw on the slide, there is a find method built into strings, right? And so what that does is basically a find, it searches the substring for a substring in this main string that it's representing. And so here in this case, my string represents this whole thing here. And then if we did dot find and put something to search in there, like the word there, it would find that position of where that occurs, right? So if you ran this, you would expect to print out a number. Right, so it returns 6. So if we think about what that means, if you look at our code, 6 is 0, 1, 2, 3, 4, 5, 6. That's where it starts, right? And so you could do this to kind of piece together certain things. For example, if you wanted to include everything from the string, from the start of it to the end of it, you could do something like this, right? So Instead of printing that out, we'll store it in a variable. So now this will equal 6 or whatever this would be changed to. And then you could do that brackets, and so you could select a range, right? So you could say, okay, I want to print the whole string, but I want to start out where it found the word we're looking for, and then continue on until the end of the string. And so the end of the string is, you could find the length of the whole string with the length of len my string, right? So that's going to return this whole length. So it's going to say, okay, start at 6 or 5, and then continue on for the length of the whole string and end there. So let's see if that works. Right? So it found the piece that we're looking for and then to the end of the string using this range ability of lists. So this is fine, but you can see that it's a lot of work and it's pretty limited to basically exact matches and stuff like that, right? So of course, if this was not a uppercase T, but a lowercase t, let's print out find location. If we ran that, it would return, let's see, return -1, and then this messed up. So when the find method is run and it doesn't find what it's looking for, there's no match, it returns -1. Because -1, if you think in a list of elements, -1 can't exist because the first one's 0, so you can't give negative to a list of things because it's always positive. So -1 means did not find anything, and so it's very specific, exactly literal to what you're looking for, right? It has to be uppercase, correct, and all that stuff. And so you can imagine if you had text, more complicated text than just 3 words, like a paragraph of text, you would need a little bit more advanced features or functionality to actually manipulate that and get pieces out of it that you want. So this is where regular expressions are kind of come into play. And regular expressions are basically based around the idea that working with text is extremely difficult, right? So working with natural language text, you're working with blocks of text, it's hard to get access to it and to figure out pieces of it and pulling it apart. So basically, regular expression is a little kind of micro language, programming language, you could say, that allows you to write patterns to match text and to pull out pieces of text. And this is not just a Python thing, you'll find them everywhere. They're in every programming language, they're in every text editor, they're ubiquitous everywhere. So it's a very reusable skill to know regular expressions. And so when I say patterns, what I'm basically saying is that you are going to define your own little pattern string. For example, say if you're looking for, I just want to find the numbers in this big block of text. You could say, okay, find the numbers 0 through 9, and that would match any numerical character 0 through 9, and return that. And there's also kind of special reserved keywords like match only space, like a space character or a tab character using this \s. And so basically the idea is that you combine these things together into a very long pattern and it matches exactly what you're looking for in your text blocks. Um, and so there's basically the process is you build up this pattern to find exactly what you're looking for. And then you can start thinking about how you want to extract these pieces of it. So you can do ranges like you just saw with numbers using these square brackets, and then you can group your results into specific results using parentheses. So if you're writing a very long pattern, but you just want to return just a piece of that result, you can use parentheses. And there are some reserved tokens, so reserved characters that you can't use in your pattern. If you wanted to use them in your pattern, you have to escape them with this \. And so these are kind of a lot of rules to absorb at once. So we're going to kind of do it by example and start looking at different patterns we could write. So you have to think about like what is a good use case for regular expressions. And so if you had, for example, a CSV file with every piece of data broken out into its own column, you don't really need regular expressions because the data is already separated for you, right? It's already broken out. But say you were working with something like this where you just had a big note field. This is like a web page from the Whitney. So say you just had a big block of text like this at the bottom here talking about a specific artwork. So say you had this piece of text here. So it has a lot of information all mushed together in this like tombstone block of text. It has the name of the artist, the title, the date it was created, dimensions, the museum, who purchased it, accession number, copyright statement, a lot of stuff, right? And so you can imagine if you did not have access to this data broken out into separate fields, you would be stuck with having to try to extract pieces of data from this block of text. And this is something where regular expressions could be really useful. And so the idea is, though, that you would want to reuse the same pattern on multiple statements, right? Multiple blocks of text, because you wouldn't want to have to write a new pattern for each individual piece of text like this. But the idea is that probably most of their texts are going to follow the same logical pattern. First is the artist name, then there's going to be the title, then there's going to be the year, and then they're mostly kind of the same formatting. So you could write a pattern that works across all the texts, all the blocks of text, and pull out exactly what you want for everything. So the toughest part of this, right, to begin with, is actually writing the expression you want to use. And so it's very hard to like kind of think, mentally and try to construct this pattern and hope it works, and then try it and then try to figure out why it doesn't work. So folks have created these kind of like interactive editors that let you very quickly develop a pattern with some immediate feedback, and then build it up and then get it to the point exactly where you want it to be, selecting what you want to be returning. So one of them I like to use is this Pythex site that I'll pull up here. And basically Pythex is a web app. It's just a web page that lets you develop these regular expressions. And so there's a few fields here. The first field is where you put your pattern, so where you put your regular expression, and then the second piece is where you put your text that you're trying to match on. So for us, we are trying to match on that kind of tombstone piece of text. So we would paste that in here, the whole thing. So that's that text we just saw. And then up here is where we put the pattern that we want to match. So this site also provides you this little cheat sheet, and it kind of throws us into quickly kind of thinking about what are the components of these patterns and how we develop them. So it's really difficult to kind of shift your thinking around building patterns and what they might match. But if you start looking at these characters, these special characters that they have available to you to use, you can start thinking about how they would work in the context of your string. So a period means match any character, anything. A caret up means match only at the beginning of the string. $sign means match only at the end of the string, etc. Right? And then you have these special characters like \d means match only anything that's not a digit, whereas \d means match anything that is a digit, a number, right? You can match white space, non-white space, anything that's an alphanumeric, anything that's a word, etc., right? And so once you have a pattern or a character pattern you want to match, then you have to specify how many of those things you want to match it by, so the quantifier. So if you think about this period, which means match any character, you could say, okay, match any character 5 times, and it would find the first 5 characters in the sequence, right? Or you could say match, any character 1 or more times, or 0 or more times. And so, for example, if we just put the word G in here, it's going to find the first, and it highlights the results. It's going to find the first G that it finds, right? And so what you could do is you could, there might be only actually one G in here. So let's do W, right? So it finds, all the W's in there. So you could say find W and then find any character, period. So now it matches the WE or the WH or the WI. And then you could say another character and another character, etc., right? Or you could say match W and then any character and then exactly 5 any characters. So it'd find the first 5 characters after any W. And so you notice it finds it for all of these characters, or all the occurrences of W. And so this is the kind of the situation, right? So you build up the pattern that you want to find something, and then you match on it. So it makes more sense if you have some specific use cases, right? So let's think about some use cases for what we might want to pull out of this data, right? So probably the easiest thing would be like, oh, we want to pull out the year that it was created, right? And so if you think about how you would do this with Python, you might say like, okay, well, it's usually after the second comma, and then there's a period, and then something like that. But if you look at this from a whole, you could say, well, what is a date, right? It's four numbers in a row. So if I picked um, 0 through 9, that matches all possible numbers. It finds all the numbers in the string, right? So then I could say, okay, match only 0 through 9 where it happens 4 times in a row. And with just that simple pattern, I match specifically on the date presented here, right? Another example would be, all right, so let's say we want to pull out the title. And for example, we always know that the title is going to be separate between two commas followed by a number. So you'd have to go through your data and see if this is generally true for all of your Tombstone text pieces. But you could say, okay, so there's always going to be a comma, right? And then there's always going to be a space. And then there's always going to be a bunch of characters, uppercase and lowercase. That could also include other characters, right? Like numbers and hyphens. You know, there could be some interesting titles of artworks. So we'll say any character. So we'll say period, one or more times. And so we're seeing our matches are getting kind of very unwieldy. But then there's a comma again, because we have a comma. And then we have another space. And then we have a number, 0 through 9. Right, and so this it got very greedy with what it's matching. So it goes all the way to it found this number, but it also found that it goes all the way to this number too. So this pattern still works, right? Because there's a comma here and then a number. So you have to think about how do we limit the greediness or the amount of characters that it's going to match. And so if you look down here in the quantifier, so if you use asterisk, that means 0 or more. Plus sign means 1 or more. And then if you append a question mark, it means non-greedy. So if we add a question mark here to this plus sign, it would be non-greedy, and it wouldn't try to match all the way to the final match of it, right? It would just match for the first time it finds it. It's not greedy. It doesn't keep going. So then, out of this very kind of confusing looking pattern, we get exactly what we want, right? And then you can actually use quotation marks or parentheses, sorry, to encase the string, the part of the pattern that you want to return, right? And so we're just interested in things after the comma, after the space, and then before the comma again, right? So we put it here, opening parentheses there, and then closing parentheses there. And then it would pull back just exactly what we want, right? So you could write a regular expression that theoretically goes through and pull out all the possible uh, titles of works, right? So you'd want to test this, right, and see like, well, what if what if it's all lowercase? Okay, still works. What if there's a number in there for some reason? Okay, still works. What if it's 2 words, right? Big test. Okay, it still works. So you'd have to go through and make sure that this pattern would work across the data, but that's basically kind of how you would do it, right? You'd slowly build up this pattern based on the pieces of it that you want to match, and then kind of figure out what section of that pattern you actually want to return. So let's do another one. Let's say, okay, I want to pull out all the dimensions of the works. And so we know here that there is a inches here, and then there's also centimeters. So it looks like the centimeters might be a little bit more easy to kind of pull out. And so what we need to do is think about, okay, well, there is what are the characteristics of this text, right? So we know it starts with a parentheses and it ends with the word CM and parentheses again. So we could write that pattern pretty easily, right? So we could say parentheses. And so here we're going to get into a problem where it's saying regular, unbalanced parentheses. So if we look at our special characters, parentheses are special in regular expressions. So if you're going to use a special character, you have to escape it. So in this case, we'll escape it with a backslash. And so now it's not looking at the parentheses as a special character to use in the pattern, it's looking at it as a literal parentheses, the actual text of parentheses. So we know it has a parentheses, then we have a bunch of stuff. So we'll say dot star, and here's matching everything, right? And then we know it ends with the letters CM and another escape parentheses. So that matches exactly what we want. And then we would have to think about, well, how would we match the specific pieces of the dimensions inside of that, right? So this is good, but if we just wanted that, maybe throw that into some note field or something, we just want to pull it out. But if we wanted to actually pull out the width and versus height, we need to know those differences, right? We need to pull out 20 versus the whole thing. So what we can do, right, is this pattern works. We know there's parentheses. So we know that there's always going to be number, space, separator, space, another number, right? So we could say, okay, numbers, there's a range of numbers like that. So that matches that. We know that there's at least one of those or more. Then we know that there is going to be there could be a decimal, right? In the example, for example, the 19.7, there's a decimal. So this 20 could be most likely something else, right? What if it was 20.5? So there could be a decimal sometimes, and there could not be a decimal sometimes. So we know that we can match it 0 or more times, that pattern. And so what we can do is say, okay, so there might be a period, but this is a literal period, not the character period, so we have to escape it, right? So there could be a period 0 or more times, and there could be a bunch of numbers for the decimal 0 or more times. So hopefully if we change this back from 20.5 to 20, we'd see that the pattern still matches, right? It still finds it even though it's different, right? Because these asterisks mean 0 or more. So if it doesn't find it at all, it's okay. The pattern still works. You know, if this was a plus sign, then it would expect it to be there. Like we use the plus sign here because there has to be a number, at least one number to begin with. All right, so let's put this back to 5. So then we know that there is some sort of space, right? And we could say there's at least one or more spaces, right? Because what if there, for some reason, there's an extra space in here like this? So if we have one or more spaces, it still matches, right? Because it's still, you know, it's not exactly one space. If it was exactly one space, then it would be limited to just the first space. But if we're saying one or more, and then we see that there's this X character. And so if we put an X here, we notice that it doesn't work, right? And so if you investigate this a little bit more, you'd see like, well, this doesn't really look like it looks a little weird, right? So it's not really an X, it's like a multiplication symbol, right? So this comes from a website, you know, you have no idea what Unicode characters people are going to be using, so they could use various things for their separators, for their height and width and height separators. So you'd want to say like, okay, well, there's going to be something in there to separate this. And so you could say, let's try putting that exact character in there, right? So that matches it. But you could also put a range of characters in there and say like, okay, it could be a multiplication symbol, it could be a little x, it could be a big X. So if this changed to a normal X, it'd still work. If this changed to a big X, it would still work. If this changed to a total sign, it would not work, right? So you can make this a little bit more, you know, robust by saying like, okay, well, the separator could be any character. But if we're fairly certain it's going to be one of these three things, we can use this or statement with this pipe to say like, okay, it's going to be this or this or this. And there's going to be at least one or more of those, right? Then we're going to have another space, one or more of those spaces, and then we're just basically going to repeat this number and decimal possibility. and there's going to be a space again, one or more, and then there's going to be the letter CM, and then there's going to be a closed parentheses. Right, so now we have not only a pattern that matches the whole thing, but we've done it to a point where it's like individual pieces of the pattern are now defined in our pattern. So we could come back in and use special character parentheses, not literal parentheses, special characters to pull out just the height, right? And add one just to pull out only the bit about the width, or the vice versa, width and height. Right? So now we're just pulling out individual pieces. And so that's much more structured than if you just had the whole string together. You actually know the individual components of it. So you'd have to play around with this and see if the other data lines up with this and see if it works right for across most of the results that you're looking for, or most of the pieces of text you're looking for. And one last simple one, you could say like, well, maybe I want to pull out the copyright for all these works. So you can just look for the copyright symbol in this case. And then that matches. And then you'd say, okay, there's going to be, it's the last thing. So whatever is left is going to be the copyright statement. And then you could use the parentheses to group that together into only the name. So using regular expressions is the hard part is defining the pattern and building up the pattern and figuring out what to use when. All right, so we know how to build a regular expression a little bit now. So the next thing we need to do is, this is a very nice interface to build an expression and figure out how exactly it should look, what the pattern should look like. But it doesn't really do anything for us for Python. So we need to translate this pattern. So let's look at the other pattern we're doing. This kind of complicated pattern that pulls out the centimeter measurements of a work of art and look at it in our, how do you apply that pattern in a Python environment. So I'm going to go back to my editor, knowing I have this pattern. I'm going to copy it for now. And there's many different types of these sites that allow you to build this pattern. You just have to be careful. This one is designed to work with a Python regular expression compiler. And so you might find one that works with like a JavaScript compiler. And while they're mostly the same, there might be slight differences across languages, how they interpret or how they apply implement the regular expression standard. So you just want to make sure you're on one that supports the Python syntax. All right, so we're going to go back to our text editor. We're going to make a new file. We're going to call this regex test.py. And so, like most things, when we are using functionality in Python, we have to import the module that we're going to be using. And so for using regular expressions in Python, it has a RE module built in. And so this regular expression module handles all the sorts of regular expression functionality. So you have to include it into your code to get started with. So we also going to need something to search in. So we'll make a new variable to call text, and that's going to be our tombstone text, right? So there we have it there, just as an example. And so to get started with building this in Python, you have to what's called compile your expression. And so what it does is it parses your pattern code and it turns it into this like internal object. And so that makes sense, right? Because this pattern has to be very syntactically correct, right? It has to be exactly how it's supposed to be according to this regular expression pattern standards. Otherwise, it's not going to work. So it's actually like compiling your little program of a pattern into its own little program to be run inside Python. So we'll say pattern equals re.compile. And inside the compile method, you pass the pattern you want to compile. And so we'll simply just go back to our Pythex website and paste in that pattern. And you can actually define this string as a regular expression string, which will kind of help with the escape characters and stuff like that. And it just tells it, this is not a normal string, this is a regular expression string. And it also kind of helps with the editor highlighting too. So the same way we had those F strings for template strings, there's also an R string that represents the regular expression patterns. Right, so if this runs, it will compile the regular expression pattern into its own little program and store that in the pattern variable. And then we have it available for us to use. And so we can make a new variable called results and say pattern, and we'll say, and now this regular expression pattern has all these things built into it. And one of those things built into it is search. And so you can say, okay, take this pattern that we just compiled and apply it in a search functionality, and apply a search functionality to this text, right? So this is the text that we have up here. So take the pattern and apply the text to the pattern. It's a little bit backwards, right? You think you'd have the text and apply a pattern to it, but you actually have the pattern compiled. It's like its own little program, and you're feeding in text to it. So let's just print the results of that, what it says. So I'm going to head back to the I'm going to run this program, Python 3 regex test. And so what it did is that it returned kind of this string representation of a regular expression match. And so it's its own little object. It says right there it's an object. And it has these things built into it. And one of the things built into it is a span. So if you ran span, so if you ran, if you type span and you printed that out instead, you get a little list showing where it starts and end, where the pattern matched and found it in the results. There's also other ones like start and end that of course gives you those information but parsed out. And then there's also one that's really important to us called group. And so group, let's see what happens if we just run it without anything in there. So group just returns the match if you just ran it with the group with no parameters. If you put a 0 into that, it will return the whole string that it's found. If you put, and then after that, if you start putting numbers in there, it will return the specific patterns or groups you define with the parentheses. So remember in this example, we used the parentheses to define specific, delineate between the width and height. So if you say group 1, that would be the first grouping of parentheses that we defined. So there's that first 120. And then if we change that to group 2, that would be the second group of parentheses that we defined, which is the second measurement. So you could come in here and you can actually use this to pull out the measurements, right? You could say width equals group 1 and height equals group 2, right? And so now you've gone from having this blob of text that who knows what's in there to actually pulling out structured data from a certain pattern that it contains within it. And then, of course, you could do something with these, whatever you want with them. They're now variables in Python, and you can store them. So there's searches built into there. Another thing built into the compiled pattern is find all. And so if you're just curious of pulling out something really quickly, all the matches that you found for a certain pattern. So let's make a new pattern here. So we'll say pattern. In this pattern, we just want to find all the date, the year date, years, things that look like years, right? 0 through 9 that are exactly 4 of those. So post 999 AD and not BC stuff. So more recent dates, right? So if we ran that, it would compile this into a pattern. We'll call it pattern 2. And then you could say all results equals our pattern 2 dot find all, and then the text you want to apply this to. And so this will return the results as a list of results, just a list of the things that I found. Let's see if it works. Yeah, right. So there's only 1 year date in there, so it only found one, but still returned it as a list. So you still have to treat it like a list. But of course, if there was multiple dates in here for some reason, like, copyright date or something like that, then it would find that one as well and return it. So using this approach, you can really build a very complicated pattern to pull out specific things. The one last thing to do is to check to see if like the pattern worked, right? So for example, what if we're using this on a lot of text, for example, and I'll comment out this piece we just did here. What if we're doing a lot of searching over a lot of different texts and we come across one of the texts that does not have measurements, for example. And instead of the measurements in centimeters, it says, I hate. So if we modify the string here, what if it just says, I hate the metric system? So there's no centimeter measurements here in this new string. So what we do, if we ran this, we'd probably get it into an error, right? Because the pattern is not going to work. So let's see what happens. Yeah, so it says none type object has no attribute group, and that happens on line 9. So on this line here, we try to access on line 9, we try to access the group 1, and that didn't exist. So basically what happens if your compile pattern fails, like it doesn't work, it doesn't match anything, then the result of this will be none. And so what you can say is you can test for that. So you can say if result equals none, then print, do whatever you're going to do here. This one hates the metric. Right. Otherwise, then you are good to go and you can process it and pull out the group information, right? So let's run that. Right, so the pattern, it did not find the pattern, didn't match, so instead of returning it a matching object, it returns none. And so you can test to see if your result is none, and if it is none, then the pattern didn't work, the match didn't work. So you can be proactive in checking to see if your pattern is working or not. So there's a lot to learn as far as building the patterns and making a pattern that matches exactly what you want to do. But these are kind of like the building blocks of getting to where you'd want to do start working with pulling out a pattern. So for a good challenge for this would be trying to use a regular expression within some other program, right? Because you're not going to usually be writing regular expressions just for the fun of it. You'd probably be using them in a certain situation, right? So if you had a CSV data file that had like a big piece of field that had a bunch of text in it, you could use a regular expression on that. If you're working with JSON that had a big blob of text, you could use a regular expression on that. If you're using an API that returns some fields that are not structured, but just free text, you could reuse a regular expression for that. So a good challenge this week would be to try to play around with using a regular expression in a certain application, right? Using it for a specific purpose for your project or an idea of something you're working on.